Hey guys, it's MJ, the student actuary. We're talking CT5, Chapter 6. This is part 3. There have been another 2 previous videos, so watch them before you watch this one. But this one we're talking about simple increasing benefits. And what this means is that your benefit is going to be increasing just how this diagram shows. You're going to get 1 in the first year, 2 in the second year, and so forth. So, the assurance, the present value, is simply going to be this increased amount discounted, and you can see that's a random variable, so we don't know how much in advance, how much the actual benefit's going to be. But we can have this symbol here, which is our expected present value, and what we do is we sum all the possible values times the probability that they happen, and that gives us our expected value. Forget the fact that I wrote annuity there. I was being an idiot. What I meant to have written was a temporary assurance, and that can be seen that it depends on the person being, or pays out when the person dies. That's why there's a little 1 above the X. And it is exactly the same formula, except this time it is limited by n minus 1. Now, these ones are nice and easy because majority of the time they are tabulated in the orange book. What isn't always in the orange book is these guys. So, how do you solve when you have to solve one of these? I'm going to show you a very quick and easy method to figure out these equations, and yeah, what you basically have to do is build blocks. So if we show here, this is what this guy over here is equal to, and all these values are tabulated in the orange book. And how we get to this, instead of learning this formula off by heart, what you can do is you can draw a diagram. So draw your diagram. I like to start with the white one, which is the whole life assurance. So you draw your little step value. Then you can see that your temporary one is going to be less than this one. And we know this because it can quite easily fit inside. Then what we do is we fit the rest in, and the big trick is over here is to split this into a normal assurance and an increasing by 1 assurance over here. Remember that n value, and then you can see those guys are subtracted from this value. And the big thing to remember is this pink term, which is your decommutation functions, and this is going to account for the force of mortality and the force of interest, as we've seen in previous videos. So yeah, that is increasing. When it comes to decreasing, again, just draw your little blocks. So in this case, I started with the red one, and that was just a normal assurance, bulked up by n plus 1. And then I found that if I subtract a temporary assurance, I'm going to get the decreasing. And remember, that one over there is that over there. So it can get quite messy. That's why I draw these diagrams out. They will help. And always remember if you need to have this pink term. But let's talk about some examples. So, example of an increasing term assurance. What we need to do is calculate the expected present value of an increasing 20-year term assurance. It's payable at the end of year to a life age 45. The benefit is 20 and it increases by 2 every year, and it gives us our mortality table. So the expected present value, this is it over here. First thing you want to, or should pop out to you, is why don't we have a 20 over here? And the reason why we don't have a 20 over here, we could have a 20, but then that's going to make this would be a different age here. That would be like 46 and 19. And so to make it the same base, what we do is we borrow 2 from this here, and we add it to the increasing annuity. So we have a level annuity and the increasing annuity starting at the same time. It just makes our mathematics much more simpler. So These values aren't tabulated, but what is tabulated when they equal 65 or 60, which in our case 45 and 20, they are tabulated, but this is for the endowment assurance. You just have to make your correction and you can get the value. So we've got that one. To get the increasing, we draw a little diagram, and basically it's that formula above just written out. You can pause the video and read this, and then bam, there's your final answer. Then I'm just going to very quickly go through this. These are the increasing annuities. They kind of work very much on the same principle as your assurances. There are some nice little relationships to look into, like IAX is equal to IA in advance X minus, as you can see, the little white blocks in between. Then it's kind of very much the same logic when it comes to increasing temporary annuities and decreasing annuities. So what we'll do is we'll do a quick example. I don't want these videos to be too long. So here we go. Example of an increasing life annuity. Calculate the expected present value of a whole life annuity to a man age 60, pays 10, increases by 1 each year, and that's a mortality table. So if we were to draw this on a timeline, we'd see 10, 11, 12, 13, okay? But like I said, rather break it up and let the increase start at the same time. So have it as 9 as your standard annuity, and then have your increasing annuity starting at the same time. And then what this does is makes your maths very nice, the fact that they both start at the same time, and you can get that from the tables. You can just make an adjustment for this one because they don't give you the values in advance. You have to, so that's the value in advance minus the normal annuity, which you've already looked up because it's the same base, so you've saved time, and there's your answer. I've also got a decreasing temporary annuity due. Feel free to pause the video and read through this one yourself. It's kind of like the same logic, just this time we do have this pink term, and think to yourself, why do you have the pink term? And yeah, that's all for this video. In the next video, I will be talking about bonuses. I don't know when I'm going to make this video because I'm going to go have some breakfast now. But yeah, that will be in the next video, which will be CT5 chapter 6.4. But yeah, thanks for watching, guys. Comment in the comment section below if I talked quickly or if you have any other questions. Thanks. Cheers.